Here's Worksheet 3 from Section 1.4, additional examples on finding the exponential curve. So the first one, we want to find y equals ab to the x, the exponential curve that contains the points 0, 8 and 6, 1, 12. Now that 0, 8 is nice because that's the y-intercept. So without doing any work, I know a is going to equal 8. But just to show it, when y is 8, so I'm going to use that point, 0, 8. When y is 8 equals a, b to the x is 0. So we get 8 equals a times 1, 8 equals a. So now I know y equals 8b raised to the x, but I still have to find b. So I'm going to use this other point. So this is my x, my y. 112 is equal to 8 times b, I don't know, but I know my x is 6. So now I have to solve for b. I'm going to divide both sides by 8. And we get b to the 6 equals 14. Now I have to solve for b, so I'm going to raise both sides by 1/6. So b equals 14 to the 1/6. Now it really should be plus or minus. This is an even power, so when I'm taking the 6th root of both sides, it is plus or minus, but because it's an exponential curve and not a skills problem trying to solve this equation, since I'm looking for an exponential curve, I know it has to be positive. The base has to be greater than 0 and other than 1. So it's going to be just the positive 14 to the 1/6. So b equals 1.552. So here's my b, here's my a. I'm looking for that equation. So y equals a, 8 times b, 1.552 raised to the x. Now if we were to check this, 8 times 1.552 raised to the 6, I'm going to check this point, raised to the 6, when I hit enter, we should get something pretty close to 112. I say pretty close because this b was rounded. So if I hit enter, what do we get? 111.7996. The more digits we go to out here, the better that approximation is going to be. But that one's close enough. For number 2, notice we don't have the y-intercept, so I'm going to have to go through, and for my first point, my x, my y, I'm going to label this one x1, y1. So it's my y is 45 equals a, b to my x of 5. Now my second point, x2, y2, is going to be 1.2 equals a, b to the 12th. Now notice I don't know a, I don't know b. Here in my second equation, I don't know a, I don't know b. So I'm going to have to somehow get down to one equation, one unknown. So I'm going to take that 1.2 equals a, b to the 12th, and I'm going to divide by 45. And again, I did this one a little lighter because I don't want a 45 there. I want what's equivalent to 45. What's equivalent to 45 is ab to the 5th. So we have a, b to the 5th. And that's going to reduce to 1.2 over 45 equals, my a's would cancel, b, same base, dividing, subtract, or exponents. 12 minus 5 is going to be b to the 7th. Now the more you do of these, the faster you're going to get. Notice I'm going to reduce this equation. I did this in the lecture as well. So this right here is my y2. So this would be your shortcut for these. So this is going to be y2 over y1 equals ab to the x2 over ab to the x1. And these cancel, so this is y2 over y1 equals same base dividing, subtract, or exponents, b to the x2 minus x1. So this formula would be your shortcut if you're looking for an exponential curve with two different points where you do not have the y-intercept. So we'll use this one in question number 3 and question number 4. But look back in those notes and you can see, pick which method you prefer. If you want to continue doing it this, or if you want to use that shortcut, you can. So we're going to get back to solving this problem now. So we have b to the 7th equals 1.2 divided by 45. So b is going to equal 1.2 divided by 45 raised to the 1/7. And again, that's the 7th root if you prefer using the roots in this. So 1.2, I'm going to clear that because I need parentheses. 1.2 divided by 45, close our parentheses, because it's all of this raised to the 1/7. And we get 0.5959. So we just want to be careful on our rounding. Now that I know b, I'm going to pick either one of these equations to find a. So I'll go back to this one. This is going to be 45 equals, I don't know a, but I do know b, 0.5959 to the 5th. So I'm really using this point here to the 5th. So to solve this for a, we're going to divide by 0.5959. So it's a equals 45 divided by 0.5959 to the 5th. And as we do that, 45 divided by 0.5959 to the 5th, we get 598.89. So when I put these together, y equals 598.89 times 0.5959 to the x. And that's our exponential curve. Now again, this is rounded, and this is rounded, so we should be in the ballpark. It's not going to be exact, but we can see how close we are. 598.89 times 0.5959 raised. So now we can check this. If we raise it to the 5th, we should get something pretty close to 45. And I hit second enter. I want to do this exactly again. But instead of the 5th, I want to use 12. And if we raise to the 12th power, we should get 1.2, or something pretty close to that. So you can see we're pretty close to 45, and we're pretty close to 1.2. These others is because of our rounding. The more you round, the more error you're going to have. So now for the next one, I'm going to go back. This time I'm going to try doing it a little quicker. Now again, quicker is not always better if you make mistakes. But because I'm not given my y-intercept, I know I have to find that base first. So I'm going to set this up. It's going to be b to the 40, that's my x minus 21, equals, this was my starting, so I got to take that 1526 divided by 1,145. You don't want this x, you were dealing with our y's. This is our y divided by that y. Here's our x minus that x. So this is our difference in our x. This is our quotient in our y's. So we have b to the 19th equals 1526 over 1145. Solve that for b. b equals 1526 over 1145 raised to the 1/19th. So b is approximately, so if I'm using parentheses, 1526 divided by 1145 raised to the 1/19th, and we get 1.015. 1.015. So I have my b. Now I want to find my a. So I'm going to go back and use this equation again. For either one of these points, we'll use this one. 1145 is equal to, I don't know a, I know b now, 1.0152 raised to my x, which is 21. Now I want to solve this for a, so since it's a times, I need to divide by 1.0152 to the 21st. So a equals 1,145 divided by 1.0152 to the 21st. Which equals, now if I come over to here, now notice how that number is stored. This isn't my rounded. So if I'm going 1145 divided by that number, so 1145 divided by second negative will be that answer, and that answer is my previous line that hasn't been rounded yet. So I'm going to raise that to the 21st, and we're going to get 833.54. Now if I do my rounded version though, 1145 divided by 1.0152 raised to the 21st, so this is my rounded version, and notice I get 834.1. So as you go through, you have to be careful as to, I mean, here this is a little off, and it's just strictly from our exact using this number to our rounded version. So just be careful with your rounding. The more you round, the more error you're going to have. But we'll say 834.1. So we have our A, we have our B. Now we can put it together. Y equals 834.1 times 1.0152 raised to the x. Now again, if we go back to the calculator for a moment, if you use this number, that's fine. Just show me your work. Okay, I will be checking both these numbers to see which one you have. But if you said this was 1.02, you're going to be way, way off on this one. So just be careful with your rounding. Oh, and we should take the time to check it. So I'm just going to clear. So we have 834.1 times 1.0152 raised. So if I put 21 in, we should be close to 1145. And if I put 40 in, we should be close to 1526. So this looks pretty close to 1145, and this looks pretty close to 1526, just not as close. And again, the difference could be that rounding as we go in. But it's not horrible. So now for the fourth problem, again I'm going to go that we're not given the y-intercept. So I'm going to go b raised to the 29 minus 17 equals 78 divided by 24. So b to the 12th equals 78 divided by 24. b equals 78 divided by 24 to the 1/12. And again, because this is even, it's really a plus or minus, but because I'm looking for an exponential curve, I'm only taking the positive. If the problem was just this part here, and it said to solve that equation, you would have to have both answers. The reason we're only taking the positive is because we're looking for an exponential curve. So when we put this into your calculator, we get 1.1032. So we have our b, and again, just here, let me do it on this one. So as we go through this one, parentheses, 78 divided by 24 raised, and you can see how I don't have that box up there. Try to get it from the glare. So I need to make sure I have those parentheses, 1 divided by 12, and there's that 1.1032. So now to find a, y equals a, I know b, 1.1032 to the x. So this is what I know so far, but I can use either one of these points to plug in for my y and my x, and then I have to find a. I'll use the first one. 24 equals, I still don't know a, 1.1032. Y is 24 when x is 17. So to solve that for a equals 24 divided by 1.1032 to the 17th, which equals, so 24, oh, it's clear, 24 divided by 1.1032 raised to the 17th, and we get 4.519. So again, if it tells you to round to a certain number of decimals, if you want to go 4 decimal places, we could say 4 decimal places here, have to go to the next one, so it would be 5. So we could say 5195 if it says to the nearest 4 decimal place, tens, hundred, thousand, 10 thousandths. Put it together, y equals 4.5195 times 1.1032 raised to the x. That's our answer. We were looking for that equation. Now if we plug this in, 4.5195 times 1.1032 raised, again if I put 17 in, I should be close to 24. If I put 29 in, I should be close to 78. So if we go 17, we should be close to 24. And second enter recalls what you plugged in. So I just want to change this power now to a 29, and I should be close to 78, which is pretty close. I hope this helps. Keep working.